Covalent bonds. Now, in my previous video, I introduced the three types of bonds: ionic bonds, which I discussed in detail in the last two videos, metallic bonds, these are present in metals, and lastly, covalent bonds, which we are going to discuss in this video. Now, when we talk about atoms, except for those of noble gases, are not stable. So in order for them to be stable, they need to have full energy levels. How can they have full energy levels? In three ways: either by losing electrons, gaining electrons, or sharing electrons. Now, in our last video, I talked about ionic bonds, where we have atoms either losing or gaining electrons in order to form ions that are stable. In this video, we are going to discuss what happens when atoms share electrons in order to gain stability. And that is what covalent bonds is all about. Now, covalent bonds are bonds that are present in compounds that are formed when non-metals react with one another. So if you have one non-metal reacting with another, you're going to end up having a compound that has covalent bonds. So covalent bonds are formed when these atoms share electrons with one another. So you find that in such a case, you're going to have atoms that cannot afford to lose electrons. So which setup do they come up with? They share electrons with each other in order to have an octet configuration, full energy levels. Now let's have a peek at the periodic table. So on the right side of the periodic table is where we have our nonmetals. So a few common nonmetals are nitrogen, oxygen, carbon. We have group 7 elements. These are fluorine, chlorine, and so on. Now, if you have two of these nonmetals reacting with one another, you're going to have a situation whereby they share electrons with one another. This will lead to the formation of a type of bond known as covalent bond. So this bond is going to hold the two atoms, the two or more atoms together to form a molecule or compound. Now, in the case of the nonmetals, what happens is that nonmetals tend to have electrons that are 4 or more in their outermost energy level. Let's pause there. Electrons are arranged in energy levels. So you find that when it comes to nonmetals, they have atoms that have either 4 or more electrons in their outermost energy level. So whenever you find an atom that has 4, 5, 6, or 7 electrons in its outermost energy level, that is most definitely a nonmetal. So you find that atoms of nonmetals can either react with one another or with other nonmetals to form covalent bonds. Now let's go into examples of covalent bonds. I'm going to start with the simple examples whereby you have covalent bonds that are present in atoms of the same element. With this slide, I'm going to explain the hydrogen, oxygen, and nitrogen molecules. Now when we talk about these three molecules, we usually refer to them as diatomic molecules. And that is the reason why we write them as such: H2O2 and N2. Now in this lesson, we are going to find out how these molecules actually look like. Now let's start with hydrogen. Hydrogen has the atomic number of 1. So that means it has 1 proton and therefore 1 electron. So it's only going to have 1 electron and 1 energy level. Now we know that in the first energy level, you need to have 2 electrons for an atom to become stable. So at this point, the hydrogen atom is not stable. It needs to gain 1 more electron to gain stability. Now if you have 2 hydrogen atoms, what are they going to do? Will one lose and the other gain? Of course not. So you're going to have a scenario whereby they are going to share each of the electron with one another. So you're going to have one hydrogen atom sharing its electron with the other. So these electrons are going to be shared in an overlapping orbital as such. So what will happen is that each hydrogen atom at this point is going to be stable. Why? Because they will each have 2 electrons. Okay, let me give an example if you find this confusing. Let's imagine you and I are in a savings account. You donate 1,000 every month and I donate 1,000. So how much money do we have in between us? 3,000. So that is essentially what the hydrogen atoms do. So they each share their single electron with the other such that by the end they are both stable. So they are going to have an electron configuration of 2. Now when we talk about covalent bonds, what happens is that we usually overlap the orbitals and the electrons that are to be shared are placed within the overlapping space. One other point regarding covalent bonds. With covalent bonds, we are not interested in the core electrons. These are electrons that are found in the innermost energy levels. We're not interested in them. So there's no need for you to illustrate them. Just focus on the valence electrons. Now that is the hydrogen atom. Now when it comes to covalent bond, you can illustrate it as such. This is known as a dot and cross diagram. So dot and cross, of course, it's obvious. You're using a dot to signify an electron from one atom and a cross to signify an electron from another atom. Now you can illustrate it as such, or you can illustrate it using these horizontal lines. Now a single line represents a single covalent bond. What do I mean by a single covalent bond? I mean that there are two electrons that are being shared. Now moving on to our second example, and that is oxygen. Now oxygen atoms have an atomic number of 8. So this means that they have an electron configuration of 2, 6. So again, for them to become stable, they need to gain 2 more electrons. So in the case of the oxygen molecule, which is O2, we are going to have 2 oxygen atoms sharing electrons. Now, if you have a single oxygen atom requiring 2 electrons, 2 additional electrons in order to become stable, how many electrons will each atom need to contribute? 2. So you're going to have 2 electrons from one atom, 2 electrons from the other atom. So a total of 4 electrons are going to be shared between the 2 oxygen atoms. I want to say this: when you have a covalent bond, go through the atoms and check whether each atom has 8 electrons, no more, no less. So let's go through this and look at it. Now for the first oxygen atom, we have 4 electrons that are not being shared and 4 electrons that are being shared. So how many electrons are those? 8. So each atom has a total of 8 electrons. So 2 electrons are represented by the cross and 2 electrons by dots, to symbolize that these are from this atom and these are from the other atom. Now this is how you represent the oxygen atom using the dot and cross diagram. Now if you want to use the lines, the horizontal lines, what you're going to do is you're going to write it as such. Now remember, one line represents 2 electrons that are being shared. Therefore, 2 lines represent 4 electrons that are being shared. Moving on to our last example, nitrogen. So nitrogen also forms a diatomic molecule when you have 2 nitrogen atoms covalently bonded to one another. The electron configuration of nitrogen is 2, 5. Now for it to be stable, it needs 3 additional electrons. So in this case, how many electrons will each nitrogen atom have to contribute? 3. So you're going to have 3 electrons from one nitrogen atom, 3 from the other nitrogen atom. A total of 6 electrons that are being shared between them. So let's look at the number of electrons for each atom. Over here we have 2 electrons, and then on the overlapping orbital we have 6. So we have a total of 8 electrons, making the nitrogen atoms stable. Now, as stated before, you don't need to focus on the core electrons when representing the covalent bonds. So when using the lines, how do we depict this? Nitrogen atom is covalently bonded to another. But which type of covalent bond do we have? We have a triple covalent bond. It means that we have 6 electrons that are being shared between the 2 nitrogen atoms. And that, ladies and gentlemen, brings us to the end of this wonderful lesson. See you next time.